2, or algebra 1.
Multiple? Multiple?
Multiply. Or divide, depending on what you need to do. So in algebra 1, they taught you. And when something's being multiplied, what do you do to undo that? How do you undo multiply?
Division.
Divide. And when something's being divided, then what do you do?
Multiply.
You multiply. So look at this problem. And here x is being multiplied by 4. This says 4 times x.
4 times x divided by 5.
This way. Maybe you see it better that way. This is 4 times x, right? That's the same thing. So x is being multiplied by 4. But what else is happening to x? It's being divided by what? 5. So in this problem, because the way they set it up, we're going to have to do both. Multiply and divide. So I'm going to multiply by 5. Why?
To get rid of 5.
Why do I multiply by 5?
It's being divided by 5.
Because this says divided by 5. So if I multiply by 5, that kills off, right? If I do it on the left, I've got to do it on the right. Just like you learned in algebra 1. It's also being multiplied by 4. So what do I have to do? Divide by 4, so that'll kill off. And then if I do it on the left, I've got to do it on the right. So this simplifies to 1, and what's 1 times x?
1x? Well, it's just x.
Yeah, because we're not hillbillies. We don't have to write the 1 in front of it, even though we know it's there. We've seen it. So x is there. Now it's just do the arithmetic over here. And by the way, this says multiply these two and then divide. Doesn't matter which to do first. No. Does not. Those things are associative. It doesn't matter which you do first. So which would be easier, dividing 4 or 12 and 4, or multiplying 12 and 5 and then dividing?
12 and 5 and then dividing?
You think so? Okay, if that's so, that's correct. You know, some people don't like big numbers. I actually prefer to do smaller numbers too. It makes it easier for me. 12 times 4, or 12 divided by 4 is
3.
3, and 3 times 5 is 15. That's easier process for me to do it. It may be easier for you to do it the other way. It doesn't matter. We get to the same place. And that's how you solve the equation. Look at example 2. Sorry, 3. 3 gives you a problem like this, and I'm going to use it to demonstrate how quickly I wish for you to get. It's going to take you some time because it's a different process than what you went through in Algebra 1, but I promise you, if you will do this process, you will like the speed and the accuracy of what I'm showing you today. Because in solving this equation, could do a problem that fast and go to the next one and be done.
Like a bomb.
Following this process. Did a lot of that in my head because I've been doing it a while. So you just need to do it a while. I'm not smarter than you. I'm not more intelligent than you.
More
I
skills.
just practiced it more times. My free throws are more accurate because I've just practiced it more times.
More skills.
Okay? So let me review what we did. How many things do you see?
4.
And everybody see 4?
Yeah.
Yes? So are the other 4 things or anything like?
Yeah.
What?
The 7p and the 9p,
The 13 and the
negative
negative
5
5,
and
and
the positive 13.
Those are like things, right? So what do you want to move?
Move
did I
the
do?
negative 5 to the left.
Okay, why did I move the 7p over there? Because that's what I did, and I made it negative. I moved, I changed
So
the
you
sign.
keep positive.
Why didn't I move the 9 over to the left side?
So you can keep positive, it's easier.
I could have done that, and you could have done that. But I don't like negative things. And had I moved negative, this over here to be negative 9, and when the signs are different, I got to subtract, keep the sign of the larger negative thing I don't like. So I recognized that, and I moved the 7 over there, changed its sign, and when I added it to 9, I get positive 2. If I could avoid negative things, I'm going to try to do that. That's something that will make you faster, less inaccurate. And so now that I've got the p things over here, I moved the negative 5 over here. When I changed the sign to positive, I added both signs are the same, so I add and stay to 18 just like you were doing in first grade. Last step, how did I know to divide here? How did I know to divide by 2? Notice I didn't write that. I didn't even write those divide by 2's down. How do I know to divide now? How do I know to go to second step?
Because 2 is being multiplied by p.
And I've only got 2 things left here. I had a 2p and an 18. Are they like?
No.
Not like things. So if I've got 2 things left and they're not like, I know I've got to divide or multiply. I know I'm at that place. I know that's when I go to the second step. You feel me on this? And now I divide by 2 and leaves that. Example number 4. This one is a little more complicated because it has parentheses. So we have to add a step.
The distributive property.
Two-step property. Yeah, so what we're gonna do, some people are saying the distributive property, and that's absolutely right. But what I'm gonna phrase it to be is, you're gonna do what it says. What I want you to do, I'm gonna add a step above 1 right here. Can I call it 0.9 and not just flip you out? It's step 0.9, just before step 1. Hopefully that won't freak you out. But if you have parentheses, you want to do one more step before you apply flat terms. You want to get rid of parentheses. You want to get rid of them. And you guys are saying how to do that. Use the distributive property. That's a big D word, and I may not remember that from Algebra 1. What that really means is this. If you're going to get rid of the parentheses, you just want to do what it says to do. So let's learn how to read. See, I've got parentheses, and yesterday we talked about order of operations. It says to do things in parentheses first, right? Got it, right? Before you do any exponents or multiplying, right? Do things in parentheses. But look at the parentheses. Can you do what it's asking you to do in there?
No, because they're not.
Why not?
terms.
Not like terms. But what's it saying to do just outside the parenthesis? So you're going to do what it says. How are you going to get rid of parentheses? You're going to do what it says. You try to do what's inside, but you can't because they're not like. So you do what's outside to get rid of the parentheses. And you said multiply 3 to what? Everything in there. Not just 5x, but everything in the parentheses. Once you do what it says, the parentheses disappear. You just drop them. So how do you get rid of parentheses?
Do what it
Do
says.
what it says. So we're going to continue, go on the other side. Notice I'm putting equal signs right underneath each other. Equal signs are always stacked. I know clearly where the left side is, clearly where the right side is. If you don't do that, you're making your task so difficult. Sort of like the guy that walked in the doctor and says, doctor, it hurts when I do this.
And don't do that.
Doctor looks at him and says, don't do it. That'll be $30. So on the left side, on the right side now, I got to get rid of parentheses. How am I going to do it? How am I going to get rid of parentheses? Do what it says. Multiply -2 to negative x. Negative times negative is positive, right? -2 times positive 7 is
minus 14.
I did what it said, so I dropped the parentheses. Now I'm going to pick up the pace a little bit so you can get some work done. I'll quit talking to you. Looking on the right-hand side, are there? Oh wait. How many things do you see? The whole string.
5.
How many things?
5.
5 things. On the right-hand side, you see how many?
3.
Of those 3, are there any like?
Yes.
If they're on the same side of the equator, do you need to move, change signs, and add?
No.
You can just add, right?
Yep.
So I've got positive 2. Oh, are the signs the same or different?
Different.
So you gotta
Subtract.
and keep the
Sign is larger.
right. So what do you get?
Negative 10.
Negative 10 of them.
Minus 14.
See how quicker that is than writing all that stuff down like you had to do now. Okay. And on the right hand side, we just have this, so we're just keeping it going a little bit slow. Now, how many things?
4.
Any things that are like
Yeah.
on opposite sides of the equator?
Yes.
What do you want to move?
Move the 10
Why
to the
move
left.
that's not a 10x, it's a,
Negative
why
10.
move the negative 10x?
Because
So it stays positive on the left
So
side.
I'm going to move that negative 10 on the left, it becomes,
Positive 25x.
and notice I move, when I move, if you have to, go ahead and write it. But as I move and add, I mark things out. Especially that helps when I get a lot of things in a problem, a lot of terms. Helps me keep track of what I've done and what I haven't done. See, now I know I've only got 2 things unmarked or unmarked out. So I've got to get those things together. Well, which are you going to move?
Why did the 25x and not?
Why the negative 24 and not the negative 14?
So it gets
We want to get
positive.
it away from X thing, right? We want to get things away. Jordan,
Why is it 25x and not 5x?
good question. When I move the negative 10 over here, it becomes,
Oh, good.
and the signs are the same, so I add
And
and
stay.
stay positive. Using the adding rule. Thanks for asking. That's a great question because there were a number of people that had the same question. Great question. So when I move the 24, the negative 24 over there becomes,
10.
yeah, it becomes positive 24. Now the signs are
Different.
different, and I gotta subtract, keep the sign of the
larger.
larger one, so you end up with what Jake said.
10.
Positive 10. Now the last step, do I have 2 things?
Yes, sir.
Or are they like?
No, sir.
Now I know to go to this last step. And I divide by, because x is being multiplied, I and you don't need to do this, you're going to get to a point where you don't even write this. Because what happens the billions of times that we're going to do this, some variable you multiply by a number and you got to divide by that number, what's going to always happen?
It's gonna equal x.
It's going to bound up x. So why on God's green earth would you waste the time to keep writing that over and over? When you know it's going to be this s, that's x, right? So I'm going to divide by x, and then that's my answer. Now, is that a valid answer?
Yeah.
Absolutely. As accurate as anything else would be. It's just back in elementary school, they taught you how to reduce things. If you look in the back to Bob, Bob's not going to write 10/25, not because it's wrong, even because they will simplify it like he learned back in elementary school.
You could simplify it to 2/5. Yeah, there we go.
Isn't that 25? Well,
Oh.
because I thought
Yeah.
10 divided by 25 was 2.
That's 25 divided by
No.
Again, in reducing fractions back in 3rd grade, we find a common number that will divide both into 10 and 25. 5 goes into that twice, 5 goes into 25 5 times. Is this a valid answer?
Yep.
Is this a valid answer?
Yes.
Absolutely, you can change it to decimal. Sometimes you want answers in decimals, sometimes you want them in fractions. Know that they're all the same, therefore they're all as accurate as any other. They're all as correct as any other. Just depends on what you need. Sometimes you find what you need in the directions. It'll say leave it in reduced fraction form. That's what you need. Okay. Questions? Yesterday's homework was already asked and reminded for you to turn it in if you haven't already. You got your quizzes. These are the problems you're working on. You will not finish them today. So again, I'm going to give you a handout that has all the answers for every even problem that you're doing between 3 and 50. Make sure you show all of your work. Even problems.
Mr. Stevenson. Good? Mr. Stevenson,